Hello and welcome to my science tutorials. In today's video, we want to learn how to simplify algebraic expressions. So let's begin. So let's say we are to simplify the expression. We are to simplify the expression x on 2 minus 2y on 10 plus z on 4. Alright, so for us to simplify this expression, we need to first of all identify that these fractions are unlike fractions. It means they don't have the same denominator. So for us to be able to proceed to add or subtract, we need to find a common denominator for them. We can do that by using or finding something we call the LCM, which stands for the least common multiple. The least common multiple. How that works is we write all the denominators. So we have 2 here. Then we write the multiples of 2. So we have 2, 4, 6, 8, 10, 12, 14, etc., etc. Then we write 10. We also write the multiples of 10. So we have 10, 20, 30, 40. Then it continues. Then we take 4. We also write the multiples of 4. So we write 4, 8, 12, 16, 20, 24, etc. Now, what we need to do is that, okay, so let me continue that of the 2. So for the 2, we have from 14, we have 16, 18, 20, 22, etc. So if we look at it, we realize that we go through all of this. What we need to do is we go through all of this to find the common multiples, which means the numbers that are common for all of them. So the common multiple CM, in our case over here, if we look through the first one, we can see there is 10 here, there is 10 here, 10 is not here, 8 here, 8 here, but no 8 here. But we can see 20 over here, we can see 20 here, we can see 20 here. So we write 20. Alright, so which other number can we see? Now, if we were to extend or continue writing this, we will get other common multiples. But as at this time, since we already have the smallest that we can possibly find so far, this becomes our LCM or our least common multiple, which is now 20. So it means that they will all have a common denominator of 20. Now we need to express all these fractions as on 20. So what that means is that we take the denominator here 2. How many times will 2 go into 20? It will go there 10 times. We use the 10 to multiply the numerator over here. So we get 10x. Then minus 10 will go into 20 how many times? 2 times. Then we use that 2 to multiply the 2y we have over here. So we get 4y plus how many times will 4 divide 20? 4 will go into 20 5 times. So we use that 5 to multiply the z over here. So we get 5z. So from here, we can go ahead and try to simplify if we have anything to simplify. So if we look at all this expression, this is an x term, this is a y term, this is a z term. We have 3 different variables. There's nothing we can add, there's nothing we can subtract. So our final answer is 10x minus 4y plus 5z all on 20. So this becomes our solution for the first example. Alright, so let's go ahead and see how we can simplify another set of fraction. So assuming we have x squared on y minus y squared on x. Alright, so if we are to simplify this expression, how are we going to do that? So we are to simplify this. The first thing we need to do, as always, is to find a common multiple. For this example, because these are 2 variables, we multiply them and then they become the least common multiple. So if we multiply y by x, we get xy. Now it means that if we divide xy by y, we are going to get just x left. So that x, we use it to multiply what we have over here. So we get s cubed minus, we have x here. If we divide this xy, if we divide x by the xy, we'll get only y. So we use that y to multiply the y squared over here. So we get y cubed. So this becomes our final answer. Let's look at another expression. So we have to simplify 3x squared on 5y multiplied by 5y squared 5yz on 6x. All right, so for this particular expression, if we look at this very well, we can see that there are some things that we can cancel. So we need to cancel out some numbers and some variables. We can do that. So let me try and rewrite this expression in a way that is easier for us to cancel or to nullify some terms. So I have 3x squared over here. I can write that as 3x multiplied by x. Okay, 3x multiplied by x on 5y. Then this multiplication sign, then 5y multiplied by z on, over here this is 6x, so I can write that as 3x multiplied by 2. That will still give me 6x. So from here I can say that this 3x will cancel the 3x over here, the 5y here will cancel this 5y over here, so I'm left with x on 1 over here multiplied by z on 2 over here. So if I proceed and I multiply everything here, I am going to get xz on 2 as my answer after simplifying this expression. Alright, so let me proceed to give more examples on how to simplify these expressions. So say I have x minus 1 cube on 4x x minus 1. How am I going to simplify this particular expression? Now, for you to simplify this expression, you need to write the numerator that you have, which is x minus 1 all raised to the power cube. You need to expand that bracket or write it in a form that is easier for you to cancel. What I mean by that is, we can write this, the numerator, as x minus 1 multiplied by x minus 1 all squared. I can rewrite what I have at the top here as this over here. Then I can now divide it by 4x into bracket x minus 1. Now I have a common term at the numerator, I have a common term at the denominator that can cancel each other out. So this will cancel this, and I'm left with x minus 1 squared on 4x as my final answer. Alright, so let's say I have 24x plus 6 on 3 into bracket 4x plus 1, and I'm to simplify this particular expression. How do I go around simplifying this expression? Now if you look at this, it's not simply direct. There is something you need to do. We can see that there's an expression at the bottom here, 4x plus 1. Now let's try to manipulate the numerator in a way that we can factor a number out, get the expression 4x plus 1 at the top so that we can cancel out. Now if we look at that, the only thing we can do at the top is to factor 6 out. If we factor 6 out, we have 6 outside bracket, then into bracket. What number will you multiply by 6 to get 24? That is 4. So we have 4x over here. Then plus, what number will you multiply by 6 to get 6? That is 1. So it means 24x plus 6 can be written as 6 outside bracket, then into bracket 4x plus 1. That is, we factored out 6. Now I can now divide this by 3 into bracket 4x plus 1. So from here, this can cancel this. Now I'm left with 6 on 3, and this will give me the answer 2 as my final answer after simplifying this expression. Right, so now that we have the basics of how to simplify various algebraic fractions, no matter how the expression is given, let's go ahead and solve this particular example. So we have to simplify the following expression. 1, 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. The second expression, is kmn on 3n cube multiplied by 6k squared m cube on 2k cube m. Then the last expression is 2fg on 16h multiplied by 4gh squared on 4fh multiplied by 32fh cube on 12f cube. Alright, so these are the expressions we are to simplify as much as possible. So let's go ahead and simplify these expressions. Now you can pause the video and try your hands on these expressions to see what you get as your answer. Alright, so let's go ahead and tackle the first one. So for the first one, the expression is 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. Now straight ahead, we can cancel some things out, some numbers, some variables that are common. We can cancel them out and have our expression easier for us to simplify. So I can cancel y with the y at the top over here. I can cancel the z at the bottom with the z at the top here. I can cancel the x here with the x here. So straight ahead from the beginning, I've cancelled all the variables. So I'm left with 3 multiplied by 8 multiplied by 5 on 2 multiplied by 3 multiplied by 4. Or still from here, I can cancel this 3 with this 3 over here. I can cancel this 4, okay, with this 8, but to be left with 2. So 4 will go into 8 2 times. And then I can cancel this 2 with this 2 now. So I'm only left with 5 at the top over here. So straight ahead, my answer is 5. So this is how easy it is when you have fractions and they are multiplying each other in algebraic expression. You can cancel things out. Just take your time and do the cancellation. Alright. Or another way you can do that is, let me redo that. So I can write 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. Another way you can do this is to multiply everything you have and get your answer. So you can do that by multiplying 3 by 8 by 5. So we have 3 multiplied by 8 multiplied by 5. Then you attach the variables, that is x, y, z. Then all on 2 multiplied by 3 by 4. So 2 multiplied by 3 multiplied by 4. Then you attach the variables y, z, and then x. So at the end, you realize that this will cancel this because they are the same term. 3 here will cancel this over here. 2 here will go here 1. It will go here 4. So you are left with 4 multiplied by 5 on another 4 here. And then this 4 can cancel this 4. And then you get 5 as your answer. So there are so many ways you can go around to cancel or to multiply and get your final answer. It depends on you. If you like, you can cancel straight ahead as in this first example, and then you get your final answer. Or if you like, you multiply everything before you cancel and then you do your final substitution. Alright, let's tackle the second expression. So we have kmn on 3n cube multiplied by 6k squared m cube on 2k cube m. Alright, so as usual, we can go ahead and start cancelling some, maybe n here, m here, m here. We can do that. Or we can go ahead and multiply everything, the numerator by the numerator, the denominator by the denominator, before we cancel. So let's do that in this case. If I multiply everything by everything I have at the top here, I'm going to have 6. K multiplied by k will give me k cube. M multiplied by m will give me m power 4. Then n. All divided by 3 multiplied by 2 will give me 6. Then I have n cube because there's no n here. Then I have k cube. Then m. Alright. So from here, I can go ahead and start cancelling to get my final answer. So the 6 will cancel the 6 out over here. Then the k cube will also cancel the k cube over here. So I have m power 4n over mn cube. Alright, so one of this m will cancel one of this m over here. So we'll be left with m power 3. And then this n will cancel one of the n over here. So it will be divided by n squared. So our final answer is m cubed over n squared as our final answer. Alright, let's proceed to look at the last expression that we have over here. So let me get some space. Alright, so the third expression we have is 2fg on 16h multiplied by 4gh squared on 4fh multiplied by 32fh cubed on 12f cubed. Alright, so there's a simpler way we can do this. We can start off by cancelling so that it makes things easier for us. So let's do the cancellation. So this 4, let me use another color. Alright, so the 4 here can cancel the 4 over here. Then the 16 over here can go into itself 1. It will go into 32 here 2 times. The 2 go into itself 1. It will go into 12 6 times over here. So what we are left with is now fg on h from here, the top over here, multiplied by over here we have gh squared on fh, then multiplied by here we have 2 on 6, here fh cube, here f cube. Alright, so from here we can go on ahead and start cancelling some things again. So this h here can cancel one of the h over here, so we are left with just one h. The f here can cancel the f here. Then the small h here will cancel the last h we have over here. And then we have one g over here. We have another g over here. Now we have f here. 1 will cancel this, so we have f squared left over here. So from here, the only thing we have is g and g. So we have g multiplied by g multiplied by 2h cube here on over here we have 6f squared. So g multiplied by g will give us g squared. We have h cubed. We put a 2 in front of it. Then we have 6f squared. And then you know that this 2 will go into itself 1. It will go into 6 here 3. So our final answer will be g squared h cube on 3f squared. So this becomes our final answer. Now, like I said, you can take your time and cancel one by one and rewrite what you have. Cancel again, rewrite like that until you get your final answer. Or you can multiply everything you have at the top, multiply everything you have at the bottom. Then you have some bulk numbers and variables, and then you take your time to cancel them out individually to get your final answer or your final expression. Right, so let's go ahead and look at more examples. Alright, so we have to simplify the following expression. We have the first expression, we have x plus 1 on 4 plus x minus 1 on 2. The second expression, we have x plus 3 on 2x plus 6. The last expression we have to simplify is we have 6 outside bracket 2x plus 1 squared on 3 into brackets 2x plus 1 all raised to the power of 5. Alright, so let's go ahead and simplify these expressions one after the other. So, solution. Now you can pause the video, go ahead and simplify this expression, and then we compare our answers at the end. All right, so the first expression, we have x plus 1 on 4 plus x minus 1 on 2. Now we have two different fractions that we are supposed to add. They have different denominators, so they are unlike fractions, so we need to find a common denominator for them. Now if we look at 4 and 2, the common denominator for them will be 4. Now the 4 will go into the 4 here just once, so we have that 1 multiplied by the top, we have 1 into bracket x plus 1. Then 2 here will go into 4 2 times, so we have plus that 2, you use it to multiply the numerator, so I take it again. The 2 here will divide the 4 here 2 times, so we have 2 into bracket x minus 1 at the top over here. Now we can expand the bracket and then simplify our expression. So if we use 1 to multiply everything here, we get x plus 1, then plus 2 to multiply here, we have 2x minus 2 all on 4. So this is equal to s plus 2s, that will give me 3s, 1 minus 2, that will give me minus 1 on 4. So this becomes my answer for the first expression. Alright, I have x plus 3 on 2x plus 6. Now whenever you have an expression like this, if you look at it very well, you see that there is nothing you can cancel easily, so you need to factor something out. Or write this expression in a way that you have something common at the top and at the bottom that you can cancel. So if we look at it, the top, there's nothing much we can do, so we maintain that x plus 3. But at the bottom, we can factor something out. So if we factor 2 out, we are left with 2 outside bracket, then x plus 3. That is 2 multiplied by x will give us 2x. 2 multiplied by 3 will give us 6. Now I have x plus 3, x plus 3 over here, so I can cancel them. So this cancels this. So over here at the top, we are left with 1, and then at the bottom, we are only left with 2. So our answer for the second expression is half. Alright, let's go ahead and tackle the last expression. So the last expression, we have 6 into bracket 2x plus 1 squared on 3, then 2x plus 1 raised to the power 5. As usual, we need to rewrite these expressions in a way that is easier for us to cancel some things out. So if we look at it very well, I can decide to factor something out at both the numerator and the denominator. So I've decided to rewrite the 6 over here as 2 multiplied by 3 into brackets 2x plus 1 all square. Okay, this is the same thing. It means 2 times 3, which will give me the 6 over here. Then on over here, I can decide to rewrite this as 2x plus 1 raised to the power 3, then multiplied by 3 raised to the power 2x plus 1 all squared. All that I've done here is I've rearranged this expression. So I've rewritten the 2x plus 1 raised to the power 5 as 2x plus 1 squared multiplied by 2x plus 1 cubed. So if this multiplied by this will give me this. Okay, so this expression, I've rewritten it as this, and I've decided to bring the 3 here in front of the first one over here. I've decided to bring the 3 in front of it over here so that it makes the expression easier. So from here, I can see that this and these are the same, so I can go ahead and cancel them. So once this and this cancels each other out, we are left with 2 at the top on, then I have 2x plus 1 all cubed at the bottom as the answer for the last expression. So thank you so much for watching. This is just a brief examples on how to simplify fractions in algebraic expression. Now we'll be looking at part 2 of this tutorial, where we'll look at more complex fractions and how we go around simplifying all those expressions. So thank you once again for watching, and I will see you in the next video. Bye bye.